Hi guys, welcome to Code Explode. Now, in the Python community over the last few years there's been a lot of talk about improving the performance of Python. There's been a lot of people coming up with a lot of ideas, doing a lot of research, a lot of talk, but now they've actually started to implement some of these ideas in the last two versions of Python, which are 3.11 and 3.12. So I thought it'd be fun to write some tests and see if anything has actually improved. Let's get into it. So first I thought it might be good to start off with kind of a real world test. So I've written a very simple API using Fast API, and I'm going to use a program called WRK to test how many requests per second this can process using Python 3.10, and then we're going to do the same thing with Python 3.12. Okay, so here you can see that I have Python 3.10 selected, and I'll just quickly show you the version. So it's 3.10.14. So I'm going to start my web server. Okay, that's running on that address. So this is the command I'm going to use to perform the test. We're going to run a program called WRK with 10 threads, 50 connections, and the duration will be 10 seconds. And this is the address of the API that I just created. This is running on the Python 3.10, which is the older version. Okay, so we got 3056 requests per second. I'm just going to run that again just to make sure that the second result is just in the same ballpark. Okay, yeah, the second test is pretty much the same as the first. So, okay, so for Python 3.10 we get 3013. So now let's switch to Python, the latest version of Python, Python 3.12, and run the test again. Okay, so here we've got 3.12.0. So let's start up our API again and rerun the tests. Remember that 3013 is the number to beat. So we have 2929. Let's run it again. Again, 2900. So we can see that unfortunately the new version of Python with all of the improvements is actually slower than the old version, which is very surprising to me. The only comment I can make is that this test is using a library, Fast API, and a lot of that library is most likely written in C++, so this test probably is running a lot of C++. So we're not going to see those speed improvements in this particular test as much. But the creator of Python, when people were suggesting these speed improvements, clearly said that the improvement should not make Python slower in any case, and it seems like it has made Python slower in this case, which I'm quite surprised about. But alas, let's try a different test, something more synthetic and less real world, and see how we do. So this is my second test. This test essentially creates a sequence of Fibonacci numbers. It's a kind of a balance test, so it's going to test the memory and it's also going to test the CPU because it does hold all of the Fibonacci numbers that it generates in memory. But it's all written in pure Python, so it should be a good test of the new improvements that are supposedly put into the new version of Python. So let's run it and see what we get. We're going to use the Unix time command to see how long it takes to run. This particular test is running with Python 3.10, which is the older version. And we can see that that ran in 5.9 seconds. Okay, so let's switch to the newer version of Python. And let's run it again. Okay, so the new version ran in 5.7 seconds. Interesting, so there's a slight speed improvement there for the newer version of Python, which is really good to see. Not huge, but significant, I'd say. So the next test that I've got for you, I wanted to create a test that was purely testing the CPU performance of Python. So this program essentially counts the number of prime numbers under a certain given number. So we're going to start with 3 million, and then it will count all of the prime numbers under 3 million. I'm not going to talk you through the code in this video, but I'm going to put it on my GitHub and link to it down below if you want to take a look and test it for yourself. So let's jump in. As we have done before, let's switch to the older version of Python first. And let's run it and see what we get. So with Python 3.10, the old version, we get 8.33 seconds. So let's switch over to the new version and see if we can see any improvements. Okay, so the newer version of Python with the improvements has run in 7.8 seconds. So that's a nice little speed up. I'm very impressed with that. So the final test I've got for you is a memory test. So this is essentially going to test a lot of the standard functions in Python. It's going to start off by creating a massive list of integers, 10 million integers. It's then going to sort the list. It's then going to reverse the list. It's then going to find the max and find the min and sum them together. So we're kind of testing to see if there's been any improvements in the Python standard library. So let's run it and see what we get. As always, we're going to start with the old version. So we've got 11 seconds. Okay, let's test the new one. Wow, okay, 13.23 seconds for the new version. What is going on? Why is the new version of Python slower? Yeah, I'm really surprised about this. I didn't expect this at all. So here are my results, guys. Let's go through them quickly. So for the API test, we saw that the older version of Python was slightly faster by about 2.5%. This is requests per second, so a higher number is better. For the blended test, using both memory and CPU, we found that there was an improvement with the new version of Python. It was about 3.6% improvement, which is great. For the memory test, the newer version of Python got absolutely thrashed by the older version of Python. I don't know what happened there. I will just say that I ran this test multiple times without the recording going, and I saw consistent results, so something's got screwed up in Python somehow, it seems. And that test is just much slower. So that's a win for the old version of Python. And the CPU test, we saw a nice little improvement in the new version of Python, 6.36%. But because of that terrible memory test, the new version of Python actually loses out on average by about 12%. So that's my video, guys. I'd love to hear your comments. Do you think this kind of testing is valuable? Do you think that this is not close enough to the real world, so it's kind of irrelevant? What are your thoughts? I'd love to hear them below. But again, thanks for watching, and I'll see you in the next episode.